We began working with parabolas way back in section 2.1. Now we'll define parabolas in a more general way. Notice the general way here. A parabola is a set of all points x, y in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus, which isn't on the line. Here's an example of a graph. The midpoint between the focus and the directrix is the vertex. Notice where I have it marked. And the line passing through the focus and the vertex is the axis of the parabola. Notice the directrix is in blue. The focus is in blue also. Consider the general form of the equation of a parabola based on the general second-degree equation. For a parabola, b will equal 0, but either a equals 0 or c equals 0. In other words, only one squared term in a parabola. We'll have what's called x squared parabolas and y squared. A parabola is symmetric with respect to its axis. Using the definition of a parabola, we can derive the following standard form of the equation. X minus h squared equals 4p times y minus k. Y minus k squared equals 4p times x minus h. Now, if the focus lies on the axis, p units from the directrix, if the vertex is at the origin, then the equation takes one of the following forms. X squared equals 4px, or y squared equals 4p, x squared is 4py, y squared is 4px. We're not going to worry about p in our course. So let's do some examples now. For example, if we have y equals x minus 2 squared minus 3, let's rewrite it as x minus 2 squared equals y plus 3. That gets it looking more like the standard form. X minus h equals x minus 2, so h is 2. Y minus k equals y plus 3, so k is equal to minus 3. So the vertex is at the point 2 minus 3. We have an x squared parabola, so the axis is the line x equal to 2. Let's try another example. In this case, we're going to have a y squared parabola. In this case, x minus h equals x plus 5, so h is equal to minus 5. Y minus k equals y plus 1, so k equals minus 1. We have a y squared parabola. It opens to the right. Now, this is the first one we've seen opening to the right. Notice we write down the vertex, we write down the axis. Remember that this would not be a function. All right, now let's suppose it's written in general form. How are we going to find the vertex? Well, a little more completing the square called for. Notice how I organized the x squared minus 4x, added 4, add 4 to both sides. X minus 2 squared equals 4y minus 8. Factor out the 4. The axis will be x equal to 2. The vertex will be 2, 2. Let's try another one. A y squared. This is either going to open to the right or to the left. Again, organize your elements. Y squared plus 10y equals 6x plus 40. Half of 10 is 5. Squared is 25. We add 25 to both sides. Y plus 5 squared equals 6x plus 65, or in other words, x plus 65 over 6, or 6 times x plus 65 over 6. So our vertex will be minus 65 over 6 and minus 5. The axis will be y equals minus 5.